Ever wonder how the tiny razor-sharp blade that gives you a clean shave is actually made? From ancient flint shaves to today's disposable safety razors, the process is a blend of high-tech metallurgy and precise automation. Let's walk through the step-by-step journey of a double-edged razor blade, from raw steel to the finished cartridge. Modern double-edged blades are not forged from ordinary stainless steel. They are cut from a high-carbon, carbide-rich steel that is stiffer, harder to polish, and capable of holding an edge for months without corroding. The steel arrives at the plant as long ribbons, each only about 0.004 inches thick. Did you know that the composition of this steel is so precise that it can affect how the blade feels in your hand during a shave? The ribbon is unwound and fed into a high-speed punching press that operates at hundreds of strokes per minute. The press stamps out the outline of each blade and creates the alignment holes, but the pieces remain linked together as a continuous strip of blanks. At this stage, the blanks are still soft and flexible, almost like origami waiting to be shaped. To give the steel the strength it needs, the blanks undergo a 4-step tempering cycle. Heating. The strip is passed through a blast furnace at roughly 2000 degrees Celsius for 30 seconds. Quenching. It is instantly submerged in cold water. Cold shock. The steel is held at 58 degrees Celsius for 20 seconds. Recovery. Gentle heating brings it back to room temperature. This controlled heating and cooling rearranges the steel's crystal structure, reducing internal stresses and producing a uniformly hard, durable blade. Fun fact: the cold shock step is like a steel spa treatment that reduces brittleness. After tempering, the blanks move to a grinding station. A printing unit first imprints the brand name and logo in microscopic detail. Then a series of rotating belts with progressively finer grits taper the edges to a microscopic bevel. Think of it like sharpening a pencil but on a blade level. A polishing wheel follows, smoothing the edge so it is both sharp and free of burrs. The process generates fine steel dust, which is captured by vacuum systems for safety. The continuous strip is fed into a second punching machine that snaps the individual blades apart along the previously stamped lines. Blades are collected in stacks of about 800 pieces. Random samples are pulled for rigorous quality control. Microscopic inspection of edge geometry. Pressure tests to verify blade strength. Wet paper cut tests to measure cutting force. UV light examination to spot any micro cracks. Only batches that pass every test move forward. Did you know some manufacturers claim their blades can cut through over 100 sheets of paper in a single swipe? The approved blades are placed in a vacuum chamber where a thin chromium-based layer is deposited. This coating protects against corrosion and adds a slight hardness. After coating, the blades are washed, dried, and sprayed with a non-stick polymer that lets the blade glide smoothly over skin, like applying a tiny layer of Teflon to each edge. To further inhibit rust and ensure safety, the blades are immersed in an organic oil for about 30 minutes. The oil film remains on the blade until it is packaged, ensuring it stays protected even in humid conditions. While the blades are being finished, plastic components are produced separately. Colored plastic pellets are melted and injection molded into the razor head, handle, and protective caps. These parts are cooled, trimmed, and inspected. Some handles are textured for grip, like the grip on a sports car steering wheel, to prevent slippage in wet hands. Automated assembly lines orient the plastic heads, place a cartridge, and insert the coated blades. Robotic arms attach the protective covers and add sacrificial anodes to protect against corrosion. The completed razors are collected, boxed in plastic and cardboard, and shipped worldwide. Ever notice how some razors have those tiny sacrificial bits? They're like the blade's bodyguards against rust. From a thin steel ribbon to a precision-engineered shaving instrument, each step in the manufacture of a double-edged razor blade is a careful balance of material science and robotic precision. The next time you glide a fresh blade across your skin, you'll know exactly how much engineering went into that smooth finish. If you enjoyed this behind-the-scenes look, hit the like button, subscribe for more manufacturing deep dives, and let us know which product you'd like to see dissected next. If you have any questions or comments, please leave them below. Your input matters. Share your ideas for our next video in the comments, and we'll recognize your contribution. Thanks for joining us on this exploration of the fascinating stories behind everyday things. Don't forget to like, subscribe, and stay tuned for more captivating content. Thanks for watching, and if you want to learn more, click the next video right here.